potentially a look into the future of our solar system. I guess
an eerie look into a dark mirror.
The final topic I wanted to talk about with you quickly, which is the discovery. I'll just get the new link up actually. The discovery of a giant planet, Jupiter-like planet, or planet candidate at least, transiting a white dwarf. So we have this seemingly bizarre situation where we have a huge planet about the size of Jupiter and about 14 times the mass, they think, spotted around a tiny white dwarf star 80 light years away. So this is I think it has a really sexy name. WD 1856 is the star, and WD 1856 plus 534 is the name of the planet. So slightly confusing, not particularly sexy, but you have this bizarre situation where you would usually, center any picture of a solar system on the star, but in this case, they'd think you'd centered it wrongly on the planet, and it was the sun that was, obviously they're going around a common center of gravity, but it's bizarre that the star is smaller than the planet.
Yeah, in a sense that's expected though for white dwarfs. White dwarfs are, the end state of sun-like stars. Our sun will eventually become a white dwarf. It won't form a black hole or a neutron star. It's not massive enough to do that. So instead, the white dwarf essentially represents the core of the sun or a sun-like star, I should say, that isn't fusing anymore. It's just the leftover material. And because there's no fusion, then gravity sort of takes over and it just sort of shrinks right down until the point where degeneracy pressure, which is to say the actual resistive force between the electrons and the atomic nuclei, stop further collapse. So that's why it doesn't form a black hole, because the pressure isn't high enough to overcome those forces. So you end up with this dead, hot ball, and they're very small. They're like the size of the Earth, typically. I think this one's a little bit larger. And they just cool down over time. So it takes billions of years for them to cool down, but eventually they'll become what we'd call a black dwarf. And then the universe isn't old enough for there to be black dwarfs yet, but eventually they will form black dwarfs, just dead inanimate object. Yeah. And if these stars once had planets, so this is going to happen to the sun, remember, then it's not unreasonable that some of those planets might survive. Now the inner planets probably not, because as the star evolves, you might know this, that the sun will become a giant star in its future. It will engulf probably even the Earth in the future, about 5-6 billion years time. And then after that, the outer planets will be disturbed in their orbits because of all the commotion happening on the inside. And so some of them might get ejected into deep space. Some of them might survive, and Jupiter is the most likely to survive just because it's the heaviest. It's the hardest to get out because it just has so much mass. And so this is a planet that's similar to Jupiter. And so perhaps we are looking at, in a way, Jupiter's future. This could really be where Jupiter ends up. It has to then spiral in. So this could happen. It could get kicked into an eccentric orbit through the gravitational interaction. Saturn's most likely to do it. So Saturn's pretty close. If these two guys, their orbits move, so they get into a resonance with each other, that can excite Jupiter's orbit. Jupiter could get kicked into an elliptical orbit, and then it will circularize on the point of closest approach, which could be very, very close in to the star, in fact, in this case. And then you end up with a Jupiter around a white dwarf. So that's one possible, we don't really know how this thing got there, but that's one possible explanation.
So the reason people are excited about it, or it's got a lot of fanfare, is because we'd have expected, if it developed at the position that it is, that when the star became a red giant, it would have fried or kicked it out. It shouldn't be there. Is that why this is so exciting?
It can't have been living in that orbit when the star was a main sequence star, because it would have actually been inside the star itself. It's so close. So there's no way it could possibly have always lived there. There's definitely, this is unambiguously evidence for either migration in a system, or I said unambiguously, but then it's ambiguous. The other possibility is that it actually formed in a second generation. I think that's a little bit difficult to imagine, though, just because this planet's so massive. It's hard to imagine there was enough material. But once the sun goes into this giant phase, it kind of sheds these shells of material, and that forms what's known as a planetary nebula. So some of the most beautiful things you can look at through a telescope are called planetary nebula. They're really nothing to do with planets. They're just the shells of the star being flung off. It's just a complete misnomer that, we called it that, and then we were stuck with that stupid name for whatever reason. But the planet connection could be that those shells and the material that's left over could then go on to form new planets. So this planet could be very, very young. It could have actually only recently formed in the history of this entire solar system. It could have just formed once the star died. But I have to say, I mean, that seems to me a little bit contrived, just because the amount of material that's typically found around white dwarfs, it's difficult to imagine there'd be enough to form a super Jupiter.
Yeah. So what would be the implications of this finding? Is the idea here, so if we have this cool intact planet that's very close to the star, could this be a harbour for life? And essentially, could you have these, I guess, solar systems that people thought were dead solar systems after they've gone red giant and turned into white dwarfs now become more locations where life could exist?
Possibly. So, I mean, in this case, probably not, because it's a giant planet. But look, the reason why many of us are so fascinated by these types of stars are that if they have Earth-sized planets around them, then the planet is pretty much the same size as the star. So that means that when the planet passes over the star, it blocks out some of the starlight, as happened here. It blocks out a huge amount of the star's light, potentially all of it, in fact. Yeah. And so you get these very, very deep eclipses. And because the way that we are currently looking, coming back to Venus even, the way we look for the atmospheres of planets, including exoplanets, is basically to study these eclipses. When it comes to exoplanets, that's how we do it. And we look to see if the eclipses change in depth at different colors. And if they do, that tells us there's a molecule in the atmosphere that likes to absorb light. Yeah. And so just because these stars are so small, that boosts up the signal from, I mean, for the Earth around the sun, it's 80 parts per million. So that's 0.00008. Yeah. That's how much it dips. Here, it's basically completely disappears. Yeah. So that gives you the opportunity to really precisely measure the atmosphere. You could detect biosignatures almost on the cheap compared to, you wouldn't have to build like a giant telescope. You could use these small stars as a cheat code to achieve the same thing. So that's why we're excited about them. But you're right that this isn't the obvious place to look for life, because this is a dead star after all. It's cooling down. It's difficult to imagine a civilization living on these things because the stars are just transient. They're not sustaining a constant energy output even. They're just cooling down over time. But it is possible life gets going on these things, and it would be incredibly exciting if we could find some Earths where the temperature is currently right for life. And then I think it would be the sort of target that we would be throwing a lot of telescope time at to try and detect these signatures.
Cool. Also interesting from the point of view of the thing we've been discussing offline that I won't go into.
Yeah, that's right. And these things are so small. You can't just detect Jupiters or Earths. You can detect something the size of the UK passing over the star. Yeah. So you can detect like outrageously small things, like small asteroids even passing over these objects. So small moons, things like this. So the potential to probe these systems is very deep compared to a typical star.
It's interesting what you say as well, because this could be, it's very speculative, but could be a view into the far future. So in 6 billion years, our sun is going to go through this red giant stage, or roughly 6 billion years, and probably consume the Earth, as you said. Maybe not Mars, but then these larger planets could be knocked into these closer orbits. So potentially a look into the future of our solar system. I guess
an eerie look into a dark mirror. It is kind of scary to look at these things in a way, but that's why I love astronomy. Is that astronomy really does give us the opportunity to look through time. Like both literally, when you look far away, you're looking through time because of the finite speed of light. but you're also seeing stars at different stages in their life cycle and their evolution, and that gives you opportunities to see how did stars form. We know how the sun formed because we can see stars just the same mass as the sun in the process of forming right now. Yeah. How do stars die? Like this is it. This is the end point. You can see it. So this is why astronomy is kind of special, because it's like a time machine. You get to really see things, the full scope of the life cycle.
Maybe we really do have to get to Mars to survive then.
Maybe that's the future. Yeah.
The future is basically Total Recall. So, you know,
perhaps recast. But.
There you go, with the 3 boobed women and everything.